Hi students, how you doing? So today we're going to be talking about factoring, specifically factoring out the greatest common factor. So our state standards for today is to be able to understand polynomials, which means more than one term, are closed under the operation of addition, subtraction, and multiplication with integers. We're going to be able to add, subtract, multiply polynomials, and divide polynomials by monomials. Remember, monomial means that there's just one term. So our key vocab for today is binomial, which means two terms, trinomial, three terms, the GCF, which stands for greatest common factor, factor, and the plural form would be factors. Okay, so if we'll do a little review here from what we did last time, if we want to simplify this, so that means we're going to FOIL or double distribute. So I'm going to go x times x, which gives you x squared. That gives you negative 7x. That gives you positive 4x. And that gives you negative 28. So now our like terms would be the negative 7x plus 4x. So we're going to have x squared minus 3x minus 28. Same thing over here. That's going to give me 2x squared. That gives me negative 8x. That gives me 1x. That gives me negative 4. So combine our like terms in the middle. That's going to give me 2x squared minus 7x minus 4. Okay, so now this says find the greatest common factor. So we're going to see what do they all have in common. We're going to take the largest item out. So we have a 24x squared y cubed, 8xy to the fifth. So let's look at the coefficients. So 24 and 8. Well, they both have an 8 in common, so I can take an 8 out. X squared and x, the largest we can take out of both of them is an 8, as an x. I can't take an x squared out of my second x over there. And then I have a y cubed and a y to the fifth. So the largest y I can take out is an y cubed. Alright, so we have a 5x squared and a 15x cubed. So again, they both have a 5 in common. And the largest x I can take out of both is an x squared. Number 5, we have a 3, a 9, and a 15. So the largest coefficient I can take out is a 3. We have an x squared and x, but the 15 does not have an x, so I can't take an x out of something that we don't have. So the only GCF I can take out here is just the 3. And number 6, we have a 2, 12, and 16, so I can take a 2 out. I have an x squared, an x, and an x to the fourth. The largest x I can take out is that x to the first right here. Alright, so again it says factor out the GCF. So I have a 4x to the fourth plus 24x cubed. So they both have a 4 in common, so I can take a 4 out. And then x to the fourth and x cubed, I can take an x cubed out. So now what am I left with? So what is 4 divided by 4? That gives you 1. X to the fourth over x cubed gives you x. Plus 24 divided by 4 gives you 6. X cubed over x cubed, that just reduces to 1. Now you don't have to put that coefficient 1 in front of the x, so then this would be my final answer. Now you can always check it, because if I were to go back and distribute this back out, what's 4x cubed times x? That would give you 4x to the fourth. What's 4x cubed times 6? That would give you 24x to the third. So if I multiply that back out, I better get the original expression, which is what I have here. So I know that I factored out correctly. Okay, so we got an 8y squared minus 24y, so they both have an 8 in common. So I can take an 8 out and a y. So when I factor that out, 8 divided by 8 is 1, y squared over y is just y to the first, minus 24 divided by 8 is 3, y divided by y just gives you 1, so there's no y with that last one there. So we have 8y times the quantity of y minus 3. Alright, so we've got, I believe that's 2x squared minus 8x. So again, we could take a 2x out. There we go. We can take a 2x out, so then we're left with x minus 4. with the 6n squared minus 15, I can't take a 6 out, but I can take a 3 out of both. And they both have an n in common, so I can take out a 3n. So 6, remember, divided by 3 gives you 2. N squared divided by n gives you 1n, n to the first, minus 15 divided by 3 is 5. N over n reduces to just no n. So again, remember, if I distribute this 3n back out, I better get my original expression. So what's 3n times 2n? That'd give you 6n squared. 3n times negative 5 gives you negative 15n. So that gives me my original expression. So we're done. Okay, so we got 3s squared minus 9s. So I can take a 3s out of both. Whoops, too many humps there. So then I'm left with 3 divided by 3 is 1. S squared divided by s is just s to the first. Minus 9 divided by 3 is 3. S over s reduces to 0 s's. Alright, so now we have a trinomial. The rules are still the same. So let's take a look at the coefficients. I've got a 3, a 21, and a 27, so I can take a 3 out. But I can't take an x out of all of them because this negative 27 does not have an x. So then what am I left with? 3 divided by 3 is 1. So we're left with x squared plus 21 divided by 3 gives you 7x. 27 divided by 3 gives you negative 9. Alright. So now we got a 2, a 14, a 6, and a 20. So they all have a 2 in common. I have an r to the fourth, an r to the third, an r squared, and an r. So I can take a 2r out. So 2 divided by 2 is 1. R to the fourth divided by r gives you r to the third. Minus 14 divided by 2 gives you 7. R to the third divided by r gives you r squared. Plus 6 divided by 2 gives you 3. R squared divided by r is just 1r. 20 divided by 2 gives you 10. R over r reduces to no r's. There we go. Good. So now we take a look at this one. I've got a 3, an 18, and a 5. So can I take any number out? Nope. The 3, 18, and 5 don't have anything in common. I've got an x squared, an x, and I've got 0 x's there. So this one, there is no GCF. Technically, you could always take out a 1, but that's the greatest common factor here. So we could take out a 1, but there's no other GCF other than 1. If I were to try to factor this, this would not be factored, so then we would call this prime. Okay, number 15. We have a 3, a 15, and a 3, so we can take a 3 out. I have an x to the fifth, x squared, x. So the largest x I can take out of all 3 of them is just the one x because this is x to the first power. Same thing, they all have a y in common, but the largest y I can take out is the one y there. Okay, so now I got 3 divided by 3 is 1. X to the fifth over x gives you x to the fourth. Y to the third over y gives you y squared. Minus 15 divided by 3 gives you 5. X squared over x gives you x. Y squared over y gives you y. Plus 3 divided by 3 is 1. X over x reduces. Y over y reduces. So we just have the 1. Now that's where you got to make sure. A lot of students forget to put that plus 1 there. How many terms did we start off with? This was 1, 2, we have 3 terms. So this is a trinomial. So when I factor, I still need to make sure I have 3 terms for my final expression. So that's another way to check it. Okay. So now we got 16, 8, and 20. I can take out a 4, and then they all have at least one x, x to the first power. So 16 divided by 4 is 4, x to the fourth over x is x cubed, plus 8 divided by 4 is 2, x squared over x gives you x, 20 divided by 4 is 5, x divided by x is 0 x's. Boom, done. All right, that's it for today.